There are many ways to die in the universe. A star can detonate in a supernova and vaporize everything within light years. A gamma-ray burst can sterilize an entire hemisphere of a planet in seconds. The vacuum of space can boil the fluids in your body and freeze what remains. A neutron star's magnetic field can disassemble your molecular structure from 1,000 miles away. The universe is not a gentle place. It is filled with violence on scales that dwarf every catastrophe in human history. But none of these compare to falling into a black hole, not because it is the fastest death, not because it is the most painful, but because it is the most absolute, the most inescapable, and the most profoundly terrifying end that the laws of physics permit. It is a death from which no part of you can ever be recovered, a death that separates you from the rest of the universe permanently, a death that is not merely the end of your life, but the end of your connection to every other thing that exists. A death that unfolds in perfect silence, behind an invisible boundary, witnessed by no one outside, reported to no one, remembered by nothing except the faint thermal glow of Hawking radiation that will carry the scrambled remnants of your quantum state back into the cosmos over timescales that dwarf the age of the universe by factors beyond counting. The terror is compounded by the knowledge that the process is irreversible. No technology, however advanced, can undo the crossing of the event horizon. No rescue mission can reach you. No communication can comfort you. The irreversibility is absolute, guaranteed by the causal structure of spacetime, enforced by the speed of light, confirmed by every observation of every black hole ever made. Falling into a black hole is not like any other death. It is qualitatively different. It is a death dictated not by chemistry or biology, or even by the forces between particles, but by the geometry of spacetime itself. The fabric of the universe has been folded in on you. Every direction you could move, every path you could take, every future you could imagine, leads to the same destination, the singularity, a point of infinite density and zero volume where the laws of physics break down and the mathematical description of reality itself ceases to function. The sheer number of these objects makes the terror cosmic in scale. The Milky Way alone may contain hundreds of millions of stellar mass black holes. The nearest known black hole to Earth is roughly 1,600 light-years away. Across the observable universe, with its 100 billion galaxies, the total number of black holes exceeds meaningful count. Each one is a trap. Each one offers the same fate. Each one waits, patient and silent, for anything that comes too close. The terror is also personal. This is not an abstract danger confined to the distant cosmos. If you were placed near a supermassive black hole, you would experience every phase of the fall firsthand. The gentle crossing, the growing awareness that escape is impossible, the building tidal forces, the spaghettification, the approach to the singularity, the breakdown of physics. You would experience it all, conscious, aware, alone, and unable to report a single observation to anyone outside. The concept of the event horizon as a point of no return has entered the popular imagination, but the physical reality is far stranger than the metaphor. The event horizon is not a wall. It is not a surface. It is a boundary defined by the causal structure of spacetime itself. Once crossed, the geometry of the universe has been reconfigured around you so that every possible future, every possible path through spacetime, every possible action you could take, leads deeper inside. The event horizon is not a barrier to be crossed. It is the moment when the geometry of your future changes irreversibly. According to current scientific estimates, the observable universe contains on the order of 100 billion galaxies. Nearly every large galaxy harbors a supermassive black hole at its center. Our Milky Way has Sagittarius A star, with roughly 4 million solar masses. The galaxy Messier 87 has one with 6.5 billion solar masses. Hundreds of millions of stellar mass black holes populate each galaxy, the remnants of massive stars that burned through their fuel and collapsed. The most terrifying end is not rare. It is one of the most common fates that matter experiences in the cosmos. By the end of tonight, you are going to understand why falling into a black hole is the most terrifying end the universe offers. Not the most painful, not the most dramatic, the most terrifying. You are going to understand what happens at each stage of the fall, from the approach to the event horizon to the final moments before the singularity. You are going to confront the inversion of space and time, the inescapability of the future singularity, the spaghettification of your body, the scrambling of your information, and the permanent, irreversible separation from everything and everyone you have ever known. Before we get started, if you find these mysteries as fascinating as we do, take a second to like the video or subscribe. It is a simple action, but it helps this channel reach more curious minds like yours. What makes falling into a black hole the most terrifying end is not any single feature. It is the combination of features, each one disturbing on its own, that together create an experience unlike anything else in the universe. The invisibility of the boundary, the gentleness of the crossing, the inversion of space and time, the inescapability of the singularity, the growing tidal forces, the chaotic geometry near the center, the permanent disconnection from the outside, the scrambling of your quantum information, and the final breakdown of physics itself at the singularity, where the equations that describe reality produce infinity, and the mathematical language of the universe falls silent. Now, let us begin. To understand why falling into a black hole is the most terrifying end, we must first understand the physics of the fall. We must understand what the event horizon is, what happens when you cross it, how time and space behave inside, and why the singularity is the most absolute destination in the universe. Because the terror is not in the violence. Other deaths are more violent. The terror is in the geometry. The geometry of space-time has been arranged by the most extreme concentration of mass in the universe into a trap from which escape is not merely difficult but mathematically impossible. General relativity, published by Albert Einstein in 1915, describes gravity as the curvature of spacetime caused by mass and energy. The mathematics is encoded in Einstein's field equations, 10 coupled nonlinear partial differential equations. The first exact solution was found by Karl Schwarzschild in 1916, while serving on the Eastern Front of the First World War and suffering from a fatal autoimmune disease. His solution describes the spacetime around a non-rotating, uncharged, spherical mass. The Schwarzschild solution reveals the event horizon, the boundary at the Schwarzschild radius from which nothing can escape. For our Sun, the Schwarzschild radius is roughly 1.86 miles. For Sagittarius A star, roughly 7.5 million miles. For M87 star, roughly 12 billion miles, larger than the orbit of Pluto. The event horizon is not a physical surface. It is not made of matter or energy. It is a mathematical boundary defined by the causal structure of spacetime. The light cones, which define the possible futures and pasts of every event, tilt inward at the horizon until every future-directed path leads deeper inside. The event horizon is the point where the geometry of spacetime closes around you. Every direction becomes inward. Every future becomes the singularity. The first terrifying feature of the fall is the invisibility of the event horizon. For a supermassive black hole, the tidal forces at the horizon are negligible. A freely falling observer crosses the event horizon without feeling anything unusual. No pain, no alarm, no force, no sensation of any kind. The most absolute boundary in the universe is completely invisible to the person crossing it. You would not know the moment you crossed. You would not feel the transition from the universe you could escape to the universe you cannot. The most important moment of your existence, the moment after which your fate is sealed, would pass without the slightest physical indication. This invisibility is confirmed by the equivalence principle, one of the foundations of general relativity. The local physics at the event horizon is indistinguishable from the local physics in flat space-time. No local measurement can detect the horizon. The terror is that you are already inside before you know it. The trap has closed around you in perfect silence. The second terrifying feature is gravitational time dilation. As you approach the event horizon, time slows down relative to a distant observer. At the horizon itself, time, as measured by the outside observer, stops completely. The outside observer watches you slow down, redshift, dim, and fade. A ghostly image, frozen at the edge of the horizon, growing ever fainter, lingering for all eternity, but never quite crossing. From the outside perspective, you are frozen in time, a statue at the edge of the abyss, visible but unreachable, present but inaccessible. The outside universe will continue for billions, trillions, quadrillions of years, and your image will still be there, infinitesimally faint, frozen at the moment before crossing. But from your own perspective, the crossing happens in finite time. Your clock ticks normally, your thoughts flow, you cross the horizon and continue to fall. The disagreement between your experience and the outside observer's experience is infinite. One sees finite time, the other sees infinite time. Both are correct within general relativity. The concept of the innermost stable circular orbit, at 3 Schwarzschild radii for a non-rotating black hole, marks the closest stable orbit. Inside this radius, no stable orbit exists. Matter must fall inward or escape outward. The properties of accretion disks are determined by this radius. X-ray observations of accreting black holes confirm the predictions. The mathematics works perfectly at every radius outside the horizon. The terror begins only when you cross the mathematical boundary where the geometry changes and every path leads inward. The Unruh effect, discovered by William Unruh in 1976, connects the terror to the physics of acceleration. An accelerating observer in flat spacetime perceives a thermal bath at a temperature proportional to the acceleration. The Hawking temperature is the gravitational analog. The equivalence principle connects the two. The terror at the event horizon is connected, through these equivalences, to the fundamental quantum properties of the vacuum. The most terrifying end is rooted in the deepest quantum mechanics. The Chandrasekhar limit, roughly 1.4 solar masses, is the maximum mass of a stable white dwarf. The Oppenheimer-Volkoff limit, roughly 3 solar masses, is the maximum mass of a stable neutron star. Above this limit, no known force can prevent further collapse. The matter contracts past the Schwarzschild radius. The event horizon forms. A new trap comes into existence. The most terrifying end is the inevitable consequence of stellar evolution for the most massive stars. The relationship between the terror and the concept of gravitational lensing provides one of the most vivid demonstrations of the extreme curvature. Near a black hole, light is bent by the curvature of spacetime. At the photon sphere, light orbits. Inside, light curves inward, following the geometry toward the singularity. The gravitational lensing near a black hole produces visual distortions of extraordinary beauty and strangeness. Einstein rings multiple images and the deformation of the background sky into a funhouse mirror of curved space. The visual experience of the fall, computed by numerical ray tracing, shows that the external universe is compressed into a shrinking bright disk above the falling observer. Below, darkness. The disk shrinks as you fall deeper. The light from the outside universe blue-shifted to ever higher frequencies. The visual distortions are the most beautiful and the most terrifying optical phenomenon in the universe, the geometry of your doom made visible in light. The M-sigma relation, the correlation between supermassive black hole mass and stellar velocity dispersion in the galactic bulge, shows that the growth of black holes and galaxies are linked. The terror at the center of each galaxy has been shaped by the galaxy's entire history. The most terrifying end is connected to the evolution of cosmic structure. The no-hair theorem states that a black hole is completely characterized by 3 quantities: mass, charge, and spin. All other information about the progenitor is hidden behind the event horizon. This radical simplicity of the exterior contrasts with the enormous complexity of the interior, as measured by the Bekenstein-Hawking entropy. A solar mass black hole has roughly 10 to the power of 77 microscopic states. The gap between the 3-number exterior and the enormously complex interior is the information gap. What happens to your information when you fall in? Where does it go? How is it processed? These questions are not just theoretical curiosities, they determine your fate. The concept of the photon sphere, at 1.5 Schwarzschild radii, illustrates the extreme curvature near a black hole. At the photon sphere, light itself orbits the black hole. If you hovered at the photon sphere and looked straight ahead, you would see the back of your own head. Multiple images of distant stars appear at different positions. The visual distortions are extraordinary. A hall of curved mirrors, bending and multiplying light. The same curvature that produces these stunning visual effects produces, deeper in, the lethal tidal forces that make this the most terrifying end. The formation of black holes through supernova explosions connects the terror to the life cycle of stars. When a star more than roughly 20 to 25 solar masses exhausts its nuclear fuel, the core collapses. The outer layers are expelled. If the remnant exceeds roughly 3 solar masses, no known force can prevent collapse past the Schwarzschild radius. The event horizon forms. The singularity forms. A new trap is created. A new instance of the most terrifying end comes into existence. This process has occurred billions of times throughout cosmic history. The accretion process provides a vivid picture of matter entering the trap. Gas and dust spiral inward through an accretion disk, heated by friction to millions or billions of degrees. The disk can outshine an entire galaxy. Active galactic nuclei, quasars and blazars are all powered by matter, falling toward the event horizon. Up to roughly 40% of the rest mass energy is radiated before the matter crosses the horizon. After crossing, the energy extraction stops. The matter falls freely toward the singularity. The most terrifying end begins with the most spectacular light show in the cosmos. The accretion disk, visible across billions of light years, is the bright doorway to the dark interior. The Schwarzschild radius scales linearly with mass. For Sagittarius A star, roughly 7.5 million miles. For M87 star, roughly 12 billion miles, larger than Pluto's orbit. The event horizon of the largest supermassive black holes is a vast, gentle boundary, a sphere of spacetime indistinguishable from empty space, where the crossing produces no sensation, no signal, no warning. The most terrifying end begins at the most peaceful boundary. The concept of the ergosphere adds complexity for rotating black holes. The ergosphere is the region between the static limit and the event horizon where no object can remain stationary. Everything must co-rotate with the black hole. The most terrifying end for a rotating black hole begins with the irresistible rotation of the ergosphere, the dragging of space-time that forces everything to spin with the black hole before falling in. The relationship between the event horizon and the innermost stable circular orbit defines the transition zone between stable orbit and inescapable fall. The innermost stable circular orbit, at 3 Schwarzschild radii for a non-rotating black hole, is the last place where matter can orbit stably. Inside this radius, every orbit decays. The matter spirals inward through the plunging region between the innermost stable circular orbit and the event horizon, crossing the boundary and entering the sealed interior. The transition from stable orbit to inescapable fall defines the beginning of the most terrifying end. The Blanford-Zanarczyk process shows how magnetic fields, threading the ergosphere of a rotating black hole, can extract rotational energy and launch relativistic jets extending hundreds of thousands of light years. These jets, the most powerful sustained energy sources in the universe, are powered by the region just outside the event horizon. The most terrifying end is surrounded by the most energetic phenomena in the cosmos. The trap is at the heart of the engine. The third terrifying feature begins at the event horizon and defines the entire interior. Inside the black hole, space and time exchange their mathematical roles. The radial direction, which was a spatial direction outside, becomes time-like inside. The time direction, which flowed from past to future outside, becomes space-like inside. The singularity at the center is not a place in space. It is a moment in time, a future moment, as inevitable as tomorrow, as unavoidable as next week. This is what makes the singularity truly inescapable. You cannot avoid it for the same reason you cannot avoid next Thursday. The singularity is not below you, it is in front of you, in time. Every path you could take, every direction you could move, every maneuver you could attempt, leads to the singularity, because the singularity is in the future, and the future always arrives. There is a cruel additional feature. Firing your rockets inside a non-rotating black hole does not help you avoid the singularity. It actually reduces your remaining proper time before reaching it. Any expenditure of energy hastens the end. The optimal strategy for maximizing your survival time is to do nothing, to fall freely, to accept the inevitable. The universe has designed the interior so that struggle makes things worse. The cruelest possible trap, one where fighting shortens your remaining time. The proper time from the event horizon to the singularity depends on the mass of the black hole. For a stellar mass black hole of 10 solar masses, roughly a tenth of a millisecond. The fall is virtually instantaneous. For Sagittarius A star, roughly 20 seconds. 20 seconds of consciousness inside the most absolute trap in the universe. For M87 star with 6.5 billion solar masses, possibly hours. Hours of awareness, falling toward a destination that cannot be avoided, separated from the outside universe by a boundary that cannot be crossed outward, knowing that the singularity is approaching and that nothing can stop it. The visual experience during the fall has been computed numerically. Looking outward, toward the event horizon you crossed, you would see the outside universe compressed into a shrinking circle of blue-shifted light above. The stars would appear brighter, their light shifted to higher and higher frequencies. Multiple images of the same stars would appear at different positions, each corresponding to photons that have taken different paths through the curved space-time. Looking inward toward the singularity, you would see darkness, not the darkness of empty space, the darkness of a future that has not yet arrived, the spatial dimensions perpendicular to your fall contract. The dimension along your fall stretches. You are inside a collapsing universe, a cosmology in miniature, contracting toward a future singularity. The mathematics of the interior is closely related to the mathematics of cosmological models. You are living inside a universe that is ending. The concept of the Schwarzschild interior as a cosmological model illuminates the nature of the terror. The mathematics of the Schwarzschild interior is closely related to the mathematics of contracting Friedman-Robertson-Walker cosmological models. The falling observer is inside a collapsing universe, heading toward a singularity. The terror of falling into a black hole is mathematically equivalent to the terror of living in a universe that is ending. The concept of the Penrose diagram makes the inescapability of the most terrifying end visually explicit. The interior of the black hole appears as a diamond-shaped region in the diagram, bounded by the event horizon below and the singularity above. Every future-directed world line from any point inside the diamond must terminate at the upper boundary. There is no path through the diamond that avoids the top. The diagram is the most concise visual summary of the most terrifying end, a region of space-time where every possible future leads to the same boundary. The gravitational redshift near the event horizon provides one of the most dramatic effects visible from outside. Light emitted by an object near the horizon is shifted to lower and lower frequencies. The object appears redder and redder, dimmer and dimmer, until it fades beyond detectability. From the outside, the falling observer appears to freeze at the horizon, a ghostly afterimage that fades but never quite disappears. The most terrifying end, from the outside perspective, looks like a permanent freezing, a suspension at the edge of the abyss. The strong cosmic censorship conjecture states that the maximal development of generic initial data is inextendable beyond the Cauchy horizon. For rotating black holes, the interior beyond the Cauchy horizon is indeterminate. Determinism fails. The most terrifying end for rotating black holes includes the possibility that the future beyond a certain point is genuinely undetermined by the past. The laws of physics cannot predict what happens next. The relationship between the terror and the number of black holes in the universe provides cosmic context. Each galaxy contains at least one supermassive black hole and potentially hundreds of millions of stellar mass black holes. With roughly 100 billion galaxies in the observable universe, the total number of black holes is beyond meaningful count. Each one offers the same fate. The most terrifying end is replicated trillions of times across the cosmos. As you approach the singularity, the tidal forces grow. For a supermassive black hole, they start negligibly and increase gradually, becoming perceptible only in the final moments. Then the growth accelerates. The forces double in ever shorter intervals. In the last fraction of a second, the tidal forces exceed the binding energy of molecules, then atoms, then nuclei. Your body is spaghettified, stretched along the direction of fall and compressed from the sides. Every structure at every scale is torn apart. The concept of frame dragging in a rotating Kerr black hole adds complexity to the terror. A rotating black hole drags spacetime around with it. In the ergosphere, the region between the static limit and the event horizon, spacetime is dragged so violently that nothing can remain stationary. Everything must co-rotate. The interior of a rotating black hole is more complex than a non-rotating one, with two horizons, a ring singularity, and the mass inflation instability at the inner Cauchy horizon. The terror inside a real astrophysical black hole, which always rotates, is more complex and less understood than the idealized Schwarzschild picture. The concept of the membrane paradigm provides a physical picture of the event horizon. The horizon behaves like a physical membrane with viscosity, conductivity, and temperature. The membrane absorbs matter, processes information, and radiates. The most terrifying end begins when you pass through this processing membrane and enter the sealed interior. The Strominger-Vafa counting of 1996 provided the first microscopic accounting of the Bekenstein-Hawking entropy within string theory. For a specific class of extremal black holes, the microstate count matches the Bekenstein-Hawking formula exactly. The terror has a microscopic basis, real, countable quantum states that encode the black hole's internal structure. The most terrifying end involves interaction with 10 to the power of 77 microscopic degrees of freedom. The concept of the stretched horizon, one Planck length outside the mathematical event horizon, provides the physical interface between the terror and the outside universe. The stretched horizon has genuine temperature, genuine entropy, and genuine viscosity. It processes the infalling matter. The most terrifying end begins at this quantum membrane, where the organized structure of the infalling body is first encountered by the quantum degrees of freedom of the black hole. Near the singularity, the geometry oscillates chaotically. The BKL dynamics, named after Belinsky, Kalatnikov, and Lifshitz, describe how spacetime contracts in one direction while expanding in another, switching patterns with increasing frequency and violence. Charles Misner called this mixmaster dynamics. The final approach to the singularity is not gentle. It is a violent, chaotic convulsion of spacetime itself. And then the mathematics breaks. The curvature diverges. The density becomes infinite. The tidal forces become infinite. Every physical quantity produces infinity. The spacetime ceases to be defined. The physics stops. The equations that have described your journey with such precision, that have predicted every tidal force and every visual distortion and every time dilation effect, produce, at the final moment, an answer that has no meaning: infinity. The end of description. The fourth terrifying feature is the permanence of the separation. Once you cross the event horizon, no signal can ever reach the outside universe. No message, no photon, no gravitational wave, nothing. You are permanently disconnected from everyone and everything you have ever known. The separation is not temporary, it is not reversible, it is absolute and eternal. The outside universe will continue without you. Stars will burn, galaxies will evolve, civilizations will rise and fall, and you will be inside, falling toward the singularity, unable to send a single bit of information outward. The permanence of the separation is what distinguishes this death from every other. In every other death, something remains. A body, a memory, a trace. Inside a black hole, from the outside perspective, nothing of you ever crosses the horizon. Your image fades at the edge and eventually disappears. From the inside perspective, you cross and are consumed. Neither perspective preserves you in a meaningful sense. The Bekenstein-Hawking entropy of a solar mass black hole is roughly 10 to the power of 77. The Hawking temperature is roughly 60 billionths of a Kelvin. The evaporation time is roughly 10 to the power of 67 years. Your quantum information, the complete specification of your physical state, is scrambled and distributed across the black hole's microstates, eventually to be returned through the Hawking radiation over timescales that exceed the current estimated age of the universe by a factor of more than 10 to the power of 56. The concept of the trapped surface is the mathematical trigger for the terror. A trapped surface is a closed two-dimensional surface from which all outgoing light rays converge inward. Inside the event horizon, every sphere is a trapped surface. All light, even outgoing light, heads inward. The existence of a trapped surface guarantees the singularity, according to the Penrose theorem of 1965. The Penrose-Hawking singularity theorems establish that the singularity is unavoidable under very general conditions. The proof requires only that general relativity is correct, that energy density is positive, and that a trapped surface exists. The theorems are robust. No amount of asymmetry or perturbation can prevent the singularity. The terror is mathematically guaranteed. The concept of the Roche limit provides a familiar analogue for the tidal destruction. The Roche limit is the minimum distance at which a satellite can orbit without being torn apart by tidal forces. Saturn's rings within the Roche limit are the remnants of tidally disrupted moons or asteroids. Near a black hole, every object has its own Roche limit. For a human body, near a stellar mass black hole, the Roche limit is outside the event horizon. The spaghettification begins before the crossing. For a supermassive black hole, the Roche limit is deep inside. The spaghettification begins during the fall. The relationship between the event horizon and the photon ring provides observational context. The photon ring, a sharp, bright feature formed by photons that have orbited the black hole multiple times, encodes geometric information about the near-horizon spacetime. Future Event Horizon Telescope observations may resolve this feature, providing direct measurements of the spacetime geometry near the boundary where the terror begins. The proper time from the event horizon to the singularity deserves emphasis because it determines the duration of the conscious experience inside. For a stellar mass black hole of 10 solar masses, roughly 1/10 of a millisecond. Too fast for any conscious experience. The fall is instantaneous and unconscious. For Sagittarius A star, roughly 20 seconds, long enough for full awareness. 20 seconds of falling through the most extreme environment in the universe, knowing that the singularity is approaching, feeling the tidal forces build, watching the visual field distort. For M87 star, possibly hours. Hours of solitary consciousness in a sealed, contracting universe. The most massive black holes offer the most prolonged, most fully aware experience of the most terrifying end. The density gradient inside the black hole defines the progression of the terror. Near the horizon of a supermassive black hole, the curvature is gentle. As you fall deeper, the curvature increases. The tidal forces grow. The spatial dimensions contract. The BKAL oscillations set in near the center. The transition from gentle to lethal to infinite occurs in a rush of accelerating destruction during the final moments. The density at the event horizon varies enormously with mass. For a stellar mass black hole of 10 solar masses, the average density at the horizon is roughly 200 million tons per cubic centimeter. For Sagittarius A star, roughly 1,000 kilograms per cubic centimeter. For M87 star, less than the density of air. The most terrifying end, for the largest black holes, begins in space-time less dense than the atmosphere of the Earth. The gentleness of the entrance makes the violence of the destination all the more disturbing. The Kruskal's coordinates provide the maximal analytic extension of the Schwarzschild spacetime. In these coordinates, the event horizon is smooth and the full causal structure is visible. The Penrose diagram compresses the spacetime into a finite picture, showing the interior as a diamond-shaped region bounded by the horizon below and the singularity above. Every future-directed path from inside must terminate at the upper boundary. The diagram makes the inescapability visually obvious. There is no path through the diamond that avoids the top. The connection between the terror and the concept of the holographic principle provides the deepest theoretical framework. The Bekenstein-Hawking entropy scales with area, not volume. If the fundamental degrees of freedom were distributed through the three-dimensional volume, the entropy would scale with volume. The fact that it scales with area suggests the three-dimensional interior is a projection of two-dimensional boundary physics. The most terrifying end occurs in a region whose fundamental description may be two-dimensional. The three-dimensional terror is a holographic projection. If the interior is a holographic projection, the singularity is a projection artifact. The boundary theory has no singularity. It evolves unitarily and continuously. The infinite terror at the center of the bulk is absent from the fundamental boundary description. The most terrifying end, at the deepest level, may not exist at all. Only its projection exists. Only the emergent experience is real. But the emergent experience is the only experience that matters. The falling observer does not experience the boundary description. They experience the bulk projection. They experience the tidal forces, the spaghettification, the approach to the singularity. The emergent terror is the real terror. The holographic principle does not diminish it. It explains its origin without removing its reality. The AD-SCFT correspondence, discovered by Juan Maldacena in 1997, makes the holographic principle mathematically precise. A theory of gravity in anti-de Sitter space is exactly equivalent to a quantum field theory on the boundary. The boundary theory is well-defined, unitary, and singularity-free. The terror in the bulk has a smooth, finite description on the boundary. The most terrifying end is, from the boundary perspective, an ordinary quantum process. The concept of tidal disruption events provides observational evidence for the destruction that awaits. When a star passes too close to a supermassive black hole, the tidal forces tear it apart. The stellar material forms a long stream that spirals around the black hole, producing a brilliant flare visible across billions of light years. These events have been observed dozens of times. Each one is a cosmic-scale demonstration of the spaghettification that awaits any object that ventures too close. Each confirms the physics of the most terrifying end. The upcoming Vera Rubin Observatory will detect thousands of tidal disruption events per year. Each detection will provide data on the physics of extreme tidal forces. The observations confirm that the spaghettification predicted by general relativity is observed and occurring regularly across the cosmos. The concept of the love number, a measure of tidal deformability, quantifies how objects deform in response to tidal forces. Neutron stars have specific love numbers. The measurement of these love numbers through gravitational wave observations constrains the equation of state of dense matter and the physics of tidal deformation near black holes. The most terrifying end begins with the most precisely measurable tidal interaction. But what scientists discovered next was worse than anyone expected. The core problem with falling into a black hole is not the physical destruction. Destruction happens everywhere. Stars explode, planets are sterilized, organisms decay. The universe is filled with processes that destroy physical structures. What makes falling into a black hole the most terrifying end is that the destruction is accompanied by a set of features that, taken together, create a uniquely horrible fate. The first feature is the awareness. For a supermassive black hole, you are conscious for the entire fall. You cross the event horizon without noticing. You have seconds, minutes, or hours of consciousness inside the black hole, depending on its mass. You are aware that you are falling toward the singularity. You are aware that nothing can stop you. You are aware that the tidal forces are building. You are aware that the destruction is coming. And you are aware that no one outside will ever know what you experienced. For Sagittarius A star, the 20 seconds of consciousness between the horizon and the singularity would be the loneliest 20 seconds in the history of the universe. 20 seconds during which you are the only conscious being in a sealed region of spacetime, falling toward a destination that no other conscious being has ever reached, experiencing physics that no one else will ever observe, making discoveries that no one else will ever learn. For M87 star, the experience could last hours. Hours of solitary awareness inside the most extreme environment in the cosmos. Hours of watching the geometry contract around you. Hours of feeling the tidal forces build. Hours of knowing that the singularity is approaching and that nothing in the universe can delay it by a single second. The second feature is the inescapability. Other deaths can, in principle, be avoided. A supernova can be fled. A gamma-ray burst can be shielded against. A collision can be deflected. But the singularity inside a black hole cannot be avoided because it is not a place. It is a time, a future time. You cannot avoid the singularity any more than you can avoid tomorrow. The geometry of spacetime has been arranged so that every possible path leads to the same moment. Every direction is inward. Every future is the singularity. The connection between the terror and the concept of geodesic incompleteness illuminates the mathematical nature of the inescapability. In a smooth spacetime manifold, geodesics, the paths of freely falling particles, can be extended indefinitely. In a spacetime with a singularity, some geodesics terminate after finite proper time. They reach the singularity and stop. The spacetime is geodesically incomplete. The mathematical description has a boundary, an edge beyond which it cannot be continued. The Kretschmer scalar, a coordinate-independent measure of spacetime curvature, diverges at the singularity. The divergence is present in every coordinate system. It cannot be removed by any choice of coordinates. The curvature invariants diverge. The tidal forces diverge. The terror at the singularity is a genuine feature of the geometry, not an artifact of description. Other curvature invariants diverge as well. The Weyl tensor, which measures the tidal component of curvature not caused by local matter, diverges. Every mathematical measure of curvature that can be constructed from the Riemann tensor diverges at the singularity. The mathematical failure is total and universal. The terror at the center is encoded in every geometric quantity. The concept of quantum error correction applied to spacetime shows how the terror is encoded. The bulk geometry is encoded in the boundary through a quantum error correcting code. Away from the singularity, the code is robust. The geometry is stable. The terror is moderate. Near the singularity, the code degrades. The geometry becomes unstable. The terror intensifies. At the singularity, the code fails. The geometry collapses. The terror reaches its maximum. The error correcting structure means that the information of the falling observer is protected even as the geometric description fails. The code has enough redundancy to preserve the information through the geometric collapse. The most terrifying end destroys the geometry but preserves the information. The structure is lost, but the content survives. The concept of the island formula connects the informational survival to the evaporation process. Quantum extremal islands, regions of the interior that belong informationally to the radiation, grow during evaporation. The information that was scrambled during the most terrifying end is gradually transferred to the radiation through the island mechanism. The terror is temporary in the informational sense. The scrambled quantum state is eventually returned. The page curve is the mathematical signature of this return. Rising entropy during the first half of evaporation, falling entropy during the second half. The page time, roughly the halfway point, is when the information begins to emerge in earnest. The most terrifying end has an informational expiration date, the page time, after which the scrambled information starts to be recovered. The relationship between the terror and the concept of determinism adds another dimension. If the singularity exists, geodesics terminate. The future cannot be predicted beyond the termination point. Determinism fails. The most terrifying end includes the breakdown of predictability itself. Beyond the singularity, if there is a beyond, the laws of physics cannot determine what happens next. The concept of the BKL dynamics near the singularity describes the chaotic nature of the final moments. The Kastner exponents, which describe the rates of expansion and contraction along three spatial directions, oscillate chaotically. The oscillations become more rapid and more violent as the singularity is approached. The BKL map, which describes the transitions between Kastner epochs, is chaotic in the mathematical sense. The Lyapunov exponents are positive. The most terrifying end is also the most chaotic end. The mixmaster dynamics mean that the spaghettification near the singularity is not a simple stretching. The directions of stretching and compression rotate and switch rapidly. The matter is churned, twisted, folded, and pulled in rapidly changing directions. Each change is more violent than the last. The approach to the singularity is a maelstrom of geometric distortion, the most violent mechanical process that the laws of physics permit. The firing of rockets, which in every other situation would change your trajectory and potentially save your life, here makes things worse. Any expenditure of energy reduces your remaining proper time. The optimal strategy is to do nothing. The most terrifying aspect of the inescapability is that any attempt to escape hastens the end. The universe has designed a trap where resistance is not just futile, but counterproductive. The connection between the terror and the concept of the vacuum energy near the event horizon adds quantum context. The quantum vacuum is modified by the extreme curvature near the horizon, producing the Hawking radiation. The virtual particle pairs that ordinarily appear and annihilate throughout empty space are separated by the curvature. One particle falls in, the other escapes. The black hole loses mass. The most terrifying end is accompanied by a slow, inexorable evaporation that will eventually dissolve the trap itself over timescales of 10 to the power of 67 years for a solar mass black hole. The Hawking radiation is thermal, with a temperature inversely proportional to mass. For a solar mass black hole, roughly 60 billionths of a Kelvin. For the most massive supermassive black holes, far colder still. The most terrifying end is also the coldest astrophysical environment, a thermal bath of unimaginable coldness surrounding the most extreme gravitational trap. The relationship between the terror and the second law of thermodynamics is fundamental. The second law says entropy never decreases. The most terrifying end is an entropy-increasing process. The organized, low-entropy structure of the falling body is converted into the maximally scrambled, high-entropy microstates of the black hole. The most terrifying end is the universe maximizing entropy at the most extreme rate, in the most extreme environment. And it gets worse. The third feature is the isolation. The event horizon is the most absolute barrier in the universe. No signal can cross it outward. No information can escape. You are completely, permanently, irrevocably isolated from the outside universe. No one outside will ever know what happened to you after you crossed the horizon. No one will receive your messages. No one will detect your signals. You exist in a sealed region of space-time, disconnected from everything else, falling alone toward the end. The isolation is more absolute than any isolation ever experienced by any human being. A person lost at sea can see the stars. A person in solitary confinement can hear sounds through the walls. A person dying of disease is still in the universe, still connected to everything else through light and gravity and the quantum correlations of their atoms. Inside a black hole, you are disconnected at the deepest possible level. The causal structure of spacetime itself has been severed. You are in a pocket universe, closing in on itself, heading toward its own singular end. The concept of the scrambling time connects the informational dimension of the terror to the physical experience. For Sagittarius A star, the scrambling time is milliseconds. The physical body falls for 20 seconds. But the informational identity is scrambled in milliseconds. The physical experience and the informational fate are on completely different timescales. You are physically present for 20 seconds. You are informationally scrambled in thousandths of a second. The Margulis-Levitin theorem sets the absolute limit on quantum evolution speed. Black holes saturate this bound. The informational scrambling during the most terrifying end operates at the physical maximum. No process in nature can scramble faster. The terror is the fastest informational transformation permitted by the laws of physics. The concept of the stretched horizon connects the informational scrambling to the physical boundary. The stretched horizon, one Planck length outside the event horizon, processes the infalling information. From the outside observer's perspective, the infalling matter is absorbed, processed, and re-emitted by the stretched horizon. The most terrifying end, from the outside perspective, occurs on the stretched horizon, not at the singularity. The interior journey is the inside perspective on the same process that the outside observer sees as horizon processing. The tidal disruption of stars by supermassive black holes has been observed dozens of times. These tidal disruption events, visible across billions of light years, are cosmic-scale demonstrations of the physics that makes falling into a black hole the most terrifying end. Each event confirms the predictions of general relativity for extreme tidal forces. Each event demonstrates that spaghettification is not merely theoretical but observed. The gravitational wave signals from merging black holes, detected by the LIGO-Virgo-Cagra collaboration, encode information about the spacetime near the event horizon. Roughly 90 events have been observed. Each one confirms that the exterior matches general relativity. The ring-down signals test the no-hair theorem. The waveforms match numerical solutions of Einstein's equations with extraordinary precision. The physics that produces the most terrifying end is confirmed by observation to extraordinary accuracy. The Event Horizon Telescope photographed the shadow of M87 star in 2019 and Sagittarius A star in 2022. The shadow is the silhouette of the event horizon against the glowing accretion disk. The images confirm that event horizons exist. The physics that produces the most terrifying end is not hypothetical, it is photographed. Andrea Ghez and Reinhard Genzel shared the Nobel Prize in 2020 for tracking stars orbiting Sagittarius A star for more than 2 decades. The stellar orbits confirm the mass and compactness of the central object. The physics that creates the trap is verified by decades of observation. The 4 laws of black hole mechanics, established by Bardeen, Carter and Hawking, mirror the 4 laws of thermodynamics. Black holes have genuine temperature, the Hawking temperature. They have genuine entropy, the Bekenstein-Hawking entropy. The thermodynamic framework constrains the terror. Any description of the fall must be consistent with these thermodynamic properties. The relationship between the terror and the concept of information as a physical quantity is fundamental. Information, in the physicist's sense, is the complete specification of the quantum state. It includes every position, every momentum, every spin, every charge, every entanglement relationship, every phase. This information is conserved by unitary evolution. It cannot be created or destroyed. The most terrifying end threatens to violate this conservation by destroying information at the singularity. The Landauer principle connects information to thermodynamics. Erasing 1 bit of information produces a minimum amount of heat. If information is destroyed at the singularity, the Landauer principle is violated. The connection between information and energy is disrupted. The most terrifying end threatens the deepest connections in physics. The no-hair theorem highlights the information gap between the outside and the inside. The exterior is described by 3 numbers: mass, charge, and spin. The interior has 10 to the power of 77 microstates. Where is the information? The holographic principle says it is encoded on the boundary, on the event horizon, in 2 dimensions rather than 3. The most terrifying end occurs in a region whose fundamental description may be 2-dimensional, not 3-dimensional. The connection between the terror and the vacuum structure of quantum fields adds quantum depth. The quantum vacuum is not empty. It is filled with 0-point fluctuations. Near the event horizon, these fluctuations are modified by the extreme curvature, producing the Hawking radiation. Inside, the vacuum structure is increasingly distorted. Near the singularity, the vacuum is unknown, because the classical background on which quantum field theory operates has broken down. The most terrifying end occurs in a region where even the quantum vacuum is undefined. The 4 laws of black hole mechanics constrain the terror thermodynamically. The Hawking temperature, the Bekenstein-Hawking entropy, and the 4 laws form a tight web of constraints. Any description of what happens during the most terrifying end must be consistent with these properties. The exterior thermodynamics demands that the interior be compatible. The infinite singularity is thermodynamically incompatible with the finite exterior. Something finite must replace it. The Hawking radiation, discovered in 1974, means the black hole is not eternal. It will evaporate. The evaporation time for a solar mass black hole is roughly 10 to the power of 67 years. The most terrifying end has a finite duration. The trap eventually dissolves. But the timescale is so vast that for all practical purposes, the end is permanent. The 4th feature is the destruction at every scale. Spaghettification is not merely lethal, it is total. The tidal forces near the singularity exceed the binding energy of every structure at every scale. Molecules are torn apart. Atoms are disrupted. Nuclei are shattered. The quarks and gluons that constitute the nucleons are separated. Every level of organization, from the macroscopic to the subatomic, is destroyed in a cascade that accelerates without bound. The destruction proceeds in a specific order, determined by the binding energies of the relevant structures. Chemical bonds with binding energies of a few electron volts are broken first, then atomic bonds with binding energies of tens to thousands of electron volts, then nuclear bonds with binding energies of millions of electron volts, then the strong force bonds between quarks, with binding energies of hundreds of millions of electron volts. Each threshold is crossed in succession, faster and faster, in the final fraction of a second before the singularity. The fifth feature is the breakdown of physics itself. At the singularity, the equations of general relativity produce infinity. The curvature diverges, the density diverges, every computable quantity diverges. The mathematical description of reality ceases to function. The laws of physics, which have governed every process in the universe with extraordinary precision, fail at this one point. The most terrifying end is also the most inexplicable. What happens at the singularity is not merely unknown. It is undescribable in the mathematical language of our best theory. But here is the problem. Quantum mechanics says the singularity cannot exist. The Heisenberg uncertainty principle forbids the compression of matter to zero volume. Unitarity forbids the destruction of quantum information. The Bekenstein-Hawking entropy demands finite internal structure. Every principle of quantum mechanics says the classical singularity is impossible. Most physicists believe the singularity is replaced by something finite at the Planck scale. The Planck density, roughly 5.1 times 10 to the power of 96 kilograms per cubic meter, is the density at which quantum gravitational effects dominate. The Planck length, roughly 10 to the power of negative 35 meters, is the scale at which the smooth description of spacetime breaks down. Something happens at the Planck scale that replaces the classical singularity. But what that something is remains one of the deepest open questions in physics. The information paradox, discovered by Stephen Hawking in 1974, adds another layer of terror. The Hawking radiation emitted by the black hole is thermal, carrying no information about what fell in. If the black hole evaporates completely, all information about you, your physical state, your memories, your identity, is permanently destroyed. Your quantum information is scrambled and lost. The concept of the Penrose process and the ergosphere of rotating black holes adds thermodynamic context to the terror. Roger Penrose showed that energy can be extracted from a rotating black hole through its ergosphere. For a maximally spinning black hole, up to roughly 29% of the total mass energy is extractable. The most terrifying end occurs inside the most efficient energy extraction engine in the cosmos. The concept of gravitational waves from the fall provides one final observational connection. When a compact object falls into a black hole, it emits gravitational waves that encode the trajectory of the fall. These waves carry information about the space-time geometry near the event horizon. The ring-down of the merged black hole tests the no-hair theorem. Each gravitational wave detection constrains the geometry of the region where the most terrifying end occurs. The connection between the terror and the concept of quantum complexity provides a dynamical perspective. Leonard Susskind proposed that the interior volume grows with quantum computational complexity. The complexity increases linearly for an exponentially long time. The interior deepens. The most terrifying end occurs in a growing space, a space generated by quantum computation, stretching and deepening even as you fall through it. The singularity is where the complexity exceeds the descriptive capacity of geometry. The connection between the different pictures and the concept of the Penrose-Hawking singularity theorems deserves emphasis. The theorems guarantee the singularity within classical general relativity, but the theorems require positive energy density, which quantum effects at the Planck scale can violate. They require trapped surfaces, which quantum corrections can modify. Every quantum gravity proposal avoids the singularity by modifying the assumptions on which the theorems rest. The classical guarantee of infinite terror evaporates in the quantum theory. The concept of geodesic incompleteness, the technical definition of the singularity, illustrates the nature of the classical endpoint. Geodesics terminate. World lines end. The mathematical description has a boundary. The quantum resolution replaces this termination with something finite. A bounce, a fuzzball interaction, a holographic dissolution. The geodesics continue, in some form, through the Planck scale transition. The concept of the Planck star provides the most concrete physical picture of the quantum flaw. The singularity is replaced by a compact object at the Planck density. The tidal forces reach the Planck curvature and halt. The matter bounces. The information is preserved. the Planck star eventually transitions to a white hole. The most terrifying end may have a sequel. The concept of the Planck star connects the terror to a specific physical endpoint. The singularity is replaced by a compact object at the Planck density. The tidal forces halt at the Planck curvature. The most terrifying end has a physical flaw rather than a mathematical infinity. The Planck star preserves information. It eventually transitions to a white hole. The terror may not be the final word. Most physicists now believe information is preserved. Hawking himself conceded in 2004. The island formula, developed in 2019 and 2020, confirmed that the entropy of Hawking radiation follows the Page curve, the signature of unitary evolution. Your information is scrambled, but not destroyed. It is distributed across the black hole's microstates and eventually returned through the Hawking radiation. But the return takes 10 to the power of 67 years for a solar mass black hole. Your information survives, but in a form so scrambled and so distributed that no practical measurement could ever reconstruct you from the radiation. The firewall paradox, introduced in 2012 by Ahmed Al-Mahiri, Donald Marolf, Joseph Polchinski, and James Lee, raised the possibility that the smooth crossing of the event horizon might not occur at all. For an old black hole, the smooth horizon might be replaced by a wall of Planck energy radiation. Falling into an old black hole might not be a gradual journey to the singularity. It might be instant annihilation at the horizon. The most terrifying end might be even more sudden than the classical picture suggests. The Strominger-Vafa counting of 1996 provided the first microscopic accounting of the Bekenstein-Hawking entropy within string theory. For a specific class of extremal black holes, the microstate count matches the Bekenstein-Hawking formula exactly. The terror has a microscopic basis. Real, countable, quantum states that encode the black hole's internal structure. The most terrifying end involves interaction with genuine quantum degrees of freedom, not merely a mathematical abstraction. The concept of the Penrose process connects the terror to energy dynamics. Energy can be extracted from the ergosphere of a rotating black hole. Up to roughly 29% of the mass energy is extractable for a maximally rotating black hole. The most terrifying end occurs inside the most efficient energy extraction engine in the cosmos. The ergosphere, where energy is extracted, surrounds the event horizon, where the fall begins. Something is wrong with our assumptions about what happens at the center. The classical picture says infinite density. Quantum mechanics says finite. The classical picture says information is destroyed. Quantum mechanics says it is preserved. The truth lies in quantum gravity, a theory we do not yet possess. The relationship between the terror and the concept of the no-hair theorem adds informational weight. The no-hair theorem says the exterior is described by three numbers: mass, charge, and spin. The interior has 10 to the power of 77 microstates. The gap between three exterior parameters and the enormous interior complexity is the information gap. When you fall in, your organized information becomes part of this enormous microscopic complexity hidden behind the three-number exterior. From the outside, all trace of your individuality disappears. You become indistinguishable from every other object of the same mass, charge, and spin that ever fell in. The most terrifying end is also the most anonymizing end. The whale curvature hypothesis, proposed by Roger Penrose, connects the terror to the arrow of time. The initial cosmological singularity has low whale curvature and low entropy. The singularity inside a black hole has high whale curvature and high entropy. The most terrifying end is the thermodynamic opposite of the beginning. The arrow of time points from the gentle beginning to the terrible end. But here is what makes this truly terrifying. Whatever happens at the center, whether it is a singularity, a quantum bounce, a fuzzball surface, or something entirely unknown, you cannot escape it. The geometry of spacetime has sealed your fate the moment you cross the event horizon. The most terrifying end is the most certain end. There is no reprieve, there is no miracle, there is no escape. The question of what makes falling into a black hole the most terrifying end has been explored from every angle of theoretical physics. Each approach to quantum gravity offers a different picture of the final moments, and each reveals a different dimension of the terror. The first picture is the classical general relativistic fall. According to general relativity, the fall into a non-rotating Schwarzschild black hole proceeds through distinct phases. The approach phase, during which the observer falls toward the event horizon, experiencing increasing time dilation and growing tidal forces for stellar mass black holes, or negligible effects for supermassive ones. The crossing phase, during which the observer passes through the event horizon without noticing, the boundary invisible and undetectable. The interior phase, during which space and time have exchanged roles. The singularity is in the future, the geometry is contracting, and the tidal forces are building. And the terminal phase, during which the tidal forces grow without bound, the BKL oscillations set in, the geometry convulses chaotically, and the mathematical description produces infinity. The Penrose-Hawking singularity theorems provide the mathematical foundation for the inescapability. Penrose proved in 1965 that once a trapped surface forms, geodesic incompleteness follows. World lines must terminate. The singularity must exist. The proof is topological, using techniques from differential geometry never before applied to general relativity. Stephen Hawking extended the methods. Together they established that the singularity is generic, not an artifact of symmetry or idealization. The terror is guaranteed by the mathematics. The observational constraints from the LIGO-Virgo-Cagra collaboration provide indirect information about the interior. Roughly 90 gravitational wave events have been detected. Each tests general relativity in the strong field regime. The ring-down signals test the no-hair theorem. Future detections of neutron star black hole mergers will measure tidal deformability near the event horizon. The photon ring, if resolved by the Event Horizon Telescope, will encode near-horizon geometric information. Each observation constrains the physics of the region where the most terrifying end begins. The Event Horizon Telescope images of M87 star and Sagittarius A star confirm that event horizons exist and that the exterior geometry matches general relativity. The shadow, the dark region at the center, is the silhouette of the event horizon against the bright accretion disk. The images confirm the reality of the boundary behind which the most terrifying end occurs. Future space-based detectors like LISA will detect supermassive black hole mergers with unprecedented precision. The gravitational waveforms will test the no-hair theorem and constrain the near-horizon geometry with extraordinary accuracy. Each observation tightens the constraints on the physics of the most terrifying end. The cosmic censorship conjecture, proposed by Penrose in 1969, states that singularities formed by collapse are always hidden behind event horizons. If cosmic censorship holds, the most terrifying end is always sealed behind the event horizon, invisible to the outside universe. The terror is quarantined. Let that sink in. The madness at the center never reaches the outside, but cosmic censorship has never been proven in full generality. If it fails, naked singularities could form, and the terror could be visible. The strong cosmic censorship conjecture states that the maximal development of generic initial data is inextendable beyond the Cauchy horizon. Determinism fails. The future cannot be predicted from the past beyond this point. Recent work has explored whether this conjecture holds in de Sitter spacetimes. The results are mixed. The terror inside a rotating black hole may include the breakdown of determinism itself. The wild curvature hypothesis proposed by Penrose connects the terror to the arrow of time. The initial cosmological singularity has low wild curvature and low entropy. The singularity inside a black hole has high wild curvature and high. The most terrifying end is the thermodynamic opposite of the beginning. The arrow of time points from the gentle beginning to the terrifying end. The concept of the Planck scale provides the quantum boundary for the terror. The Planck length is roughly 10 to the power of negative 35 meters. The Planck density is roughly 5.1 times 10 to the power of 96 kilograms per cubic meter. The Planck time is roughly 10 to the power of negative 43 seconds. At these scales, the classical description breaks down and quantum gravity takes over. The terror has a quantum flaw. The tidal forces reach the Planck curvature, and then something happens. Something we do not yet understand. The gap between the Planck scale and our experimental capabilities is roughly 17 orders of magnitude. The physics of the most terrifying end at the Planck scale must be determined through theory, through mathematical consistency, through the constraints of the information paradox and black hole thermodynamics. For a rotating Kerr black hole, found by Roy Kerr in 1963, the interior is more complex. Two horizons exist, an outer event horizon and an inner Cauchy horizon. Between them, space and time are inverted. Beyond the inner horizon, they revert. The singularity is a ring rather than a point. The Kerr mathematics permits paths through the ring into entirely different spacetimes. The connection between the different pictures and the concept of observer complementarity is important. In every picture, the terror is real from the falling observer's perspective. The falling observer experiences the crossing, the interior, the growing tidal forces, the spaghettification. Whether the endpoint is a singularity, a Planck star, a fuzzball surface, or a holographic dissolution, the falling observer experiences the journey up to the quantum gravitational transition. The outside observer sees a different picture, matter absorbed by the stretched horizon, processed and re-emitted as Hawking radiation. The outside observer never sees the fall. They see the matter slow down, redshift, dim and fade at the horizon. Both descriptions are valid. The terror is observer-dependent, but no less real. The concept of the Ryu-Takayanagi formula connects the informational dimension of the terror to the geometry. The entanglement entropy of a boundary region equals the area of the minimal bulk surface in Planck units. The curvature that produces the terror is encoded in the entanglement structure of the boundary state. The hostile geometry is generated by entanglement. The terror is built from quantum correlations. The quantum extremal surface formula includes quantum corrections and leads to the island formula. The islands, regions of the interior that belong informationally to the radiation, grow during evaporation. The information scrambled during the most terrifying end is transferred to the radiation through the island mechanism. The terror has an informational afterlife. The scrambled quantum state is eventually returned. The replica wormholes, saddle points of the gravitational path integral, provide the mathematical mechanism that ensures unitarity. Without them, the gravitational calculation gives the wrong answer. Information is lost. With them, the correct answer, information is preserved. The most terrifying end is consistent with the most fundamental principle of quantum mechanics. But the inner Cauchy horizon is almost certainly unstable. The mass inflation instability, demonstrated by Werner Israel and Eric Poisson, shows that infalling radiation is blue-shifted to arbitrarily high energies at the inner horizon. The elegant Kerr interior, with its ring singularity and alternate universes, is almost certainly a mathematical idealization. The actual interior of a real rotating black hole is messier, more violent, and less understood. The terror of the real interior may be worse than the terror of the idealized one. The second picture comes from string theory. In the fuzzball program, developed by Samir Mathur, the entire classical interior is replaced by a complicated structure of strings and branes. There is no smooth event horizon. There is no empty interior. There is no singularity. The black hole is a fuzzball. A falling observer would encounter the fuzzball surface before crossing the would-be horizon. What does this mean for the terror of the fall? In the fuzzball picture, the fall does not proceed through the classical phases. There is no quiet crossing, no interior journey, no gradual building of tidal forces. Instead, the observer encounters the fuzzball surface, a quantum gravitational boundary, at or near the would-be horizon. The interaction with the fuzzball surface is not well understood, but it would presumably be instantaneous and total. The terror of the gradual, conscious fall toward the singularity is replaced by the terror of sudden contact with a quantum gravitational structure of unimaginable complexity. The numbers are striking. The Bekenstein-Hawking entropy of a solar mass black hole is roughly 10 to the power of 77. The fuzzball has this many microstates, each is a different configuration. The falling observer encounters a structure with 10 to the power of 77 possible internal arrangements. The complexity is beyond comprehension. The third picture comes from loop quantum gravity. The singularity is replaced by a quantum bounce at the Planck density. The tidal forces reach a maximum and then reverse. The matter bounces. The black hole transitions to a white hole. In this picture, the fall is not the end, it is a transition. The observer falls, is compressed to the Planck density, bounces and re-emerges. The terror in this picture is different. The observer still crosses the event horizon. The observer still experiences the growing tidal forces. The observer still undergoes spaghettification. But at the extreme, at the Planck scale, the compression halts and reverses. Whether the observer's consciousness could survive the compression to the Planck density is unknown. The tidal forces at the Planck density, while finite, are unimaginably large. The Planck star, proposed by Carlo Rovelli and Francesca Vidotto, is the densest possible configuration of matter. The compression to this state would disassemble every structure in the body at every scale. Whether the subsequent bounce could reassemble anything meaningful is unknown. The fourth picture comes from the holographic principle and ADS-CFT. Juan Maldasena's 1997 discovery showed that a theory of gravity in anti-de Sitter space is equivalent to a quantum field theory on the boundary. The boundary theory has no event horizon, no interior, no singularity. The three-dimensional fall is a holographic projection of two-dimensional boundary dynamics. In this picture, the terror of the fall is real at the level of the emergent description, the three-dimensional bulk picture. But at the fundamental level, the two-dimensional boundary picture, there is no fall, there is no event horizon, there is no singularity. The terror is an emergent experience generated by the holographic projection, real to the falling observer but absent from the fundamental description. The connection between the terror and the concept of asymptotic safety provides another perspective on the quantum flaw. In asymptotically safe gravity, the gravitational coupling runs to a finite fixed point at high energies. The curvature is bounded. The tidal forces reach a maximum. The terror is finite. The classical infinity is tamed by the running coupling. Causal set theory proposes that space-time is fundamentally discrete. In a discrete space-time, the singularity cannot form. The most terrifying end occurs in a space-time with a minimum scale, a granularity that prevents infinite density. The terror reaches the discrete limit and stops. The concept of the Planck star provides a specific physical picture of what replaces the singularity at the endpoint of the terror. The Planck star has the Planck density. It has a radius of roughly the Planck length. It preserves information. It eventually transitions to a white hole. The most terrifying end in this picture is not permanent. The matter bounces through the Planck scale transition and re-emerges. The terror has a sequel. The black-to-white hole transition, explored by Haggard and Rovelli, connects to the most terrifying end to a new beginning. The collapsed matter bounces at the Planck core and expands outward. The terror is a transit, not a terminus. The information survives. The matter re-emerges. The most terrifying end is, in this picture, a passage through the most extreme conditions to a re-emergence on the other side. Whether consciousness, in any meaningful sense, could survive the compression to the Planck density is unknown. The tidal forces at the Planck density, while finite, are unimaginably large. Every structure would be disassembled, every bond would be broken. The quantum state would be preserved, but the organized structure would be destroyed. The most terrifying end preserves information, but almost certainly destroys the organized information processing that constitutes conscious experience. The concept of the arrow of time adds final weight. The most terrifying end is the thermodynamic destination. The arrow points toward it. The entropy increases during the fall. The black hole is the maximum entropy object. The most terrifying end is the endpoint of the thermodynamic journey that began with the low entropy initial conditions of the universe. The gravitational path integral, summing overall spacetime geometries, including replica wormholes, provides powerful evidence for the finiteness of the terror. Individual classical geometries contain singularities. The quantum sum does not. The infinite terror is washed out in the quantum average. The full quantum theory predicts finite tidal forces at all scales. The convergence of all approaches on the finiteness of the terror at the Planck scale is the strongest theoretical conclusion about the endpoint. Every approach identifies the Planck density as the maximum. Every approach preserves information. Every approach replaces the classical infinity with something finite. The most terrifying end has a quantum flaw, even if we cannot yet see exactly what lies on it. The thermodynamic constraints reinforce this convergence. The Bekenstein-Hawking entropy, the Hawking temperature, the four laws of black hole mechanics, the Page curve, all must be consistent. The constraints are severe. The surviving proposals all agree on the broad outline. The singularity is resolved, information is preserved, and the terror is extreme but finite. This does not diminish the terror. Temperature is emergent, but a burn is real. The fall is emergent, but the experience is real. The falling observer does not care that the fundamental description has no event horizon. They experience the crossing, the interior, the growing tidal forces, the spaghettification. The emergent terror is the only terror that matters. The connection between the terror and quantum entanglement is one of the deepest threads. The smooth vacuum at the event horizon is maintained by entanglement between modes inside and outside. The Hawking radiation arises from the separation of entangled pairs. The information paradox arises because the entanglement structure cannot simultaneously satisfy unitarity and the smooth horizon. The firewall paradox arises when the entanglement breaks. Entanglement connects every layer of the terror. It generates the smooth geometry near the horizon. It produces the Hawking radiation. It creates the information paradox. It breaks at the firewall, and it may hold the key to the resolution through the holographic principle, through ER equals EPR, through the error-correcting structure of holographic spacetime. If entanglement generates spacetime, as Van Ramsdonk showed, then the terror of the interior is generated by entanglement. The hostile geometry that makes the fall inescapable is produced by the entanglement structure of the quantum state. Near the singularity, the entanglement is maximally disrupted. The geometry reaches its most hostile configuration. The terror is the geometric expression of maximal entanglement disruption. The Page curve describes the informational life cycle of the terror: rising entropy during the first half of evaporation, falling entropy during the second half. The island formula reproduces this curve. Quantum extremal islands grow during evaporation, transferring information from the interior to the radiation. The terror has an informational aftermath. The scrambled information is eventually returned, over timescales that dwarf the age of the cosmos. The scrambling time for Sagittarius A star is milliseconds. Within thousandths of a second, the information of anything crossing the horizon is distributed across the entire boundary. The Margulis-Levitin theorem sets the maximum speed of quantum evolution. Black holes saturate this bound. The most terrifying end operates at the maximum speed of information processing. The Hayden-Preskill protocol shows that individual bits can be recovered after one scrambling time. The information survives. The person does not. The quantum state is preserved. The conscious experience is destroyed. The most terrifying end preserves everything except the thing that matters most: the organized, coherent, conscious experience of being alive. The fifth picture involves the firewall. If the AMS argument is correct, the smooth event horizon of an old black hole is replaced by a wall of Planck energy radiation. The gentle invisible crossing described by general relativity is replaced by instant incineration. The terror of the conscious fall toward the singularity is replaced by the terror of instant destruction at the boundary. There is no interior to experience. There is only the firewall. The connection between the different proposals and the thermodynamic constraints provides a unified framework. Every proposal must reproduce the Bekenstein-Hawking entropy, the Hawking temperature, and the four laws of black hole mechanics. These thermodynamic properties are established by independent calculations and confirmed by indirect observation. Any description of the most terrifying end must be consistent with the thermodynamics of the exterior. The thermodynamic constraints are powerful. The exterior temperature and entropy are finite and well defined. The interior must be compatible. An infinite singularity is thermodynamically incompatible with the finite exterior. The thermodynamics demands a finite resolution. Every proposal that satisfies the thermodynamic constraints agrees. The singularity is resolved at the Planck scale. The concept of the Page curve adds temporal structure to the informational aftermath of the terror. The entropy of the Hawking radiation rises during the first half of evaporation and falls during the second half. The island formula reproduces this curve. The information scrambled during the most terrifying end is returned through the radiation. The Terra has an informational life cycle: scrambling, storage, and return. The sixth picture involves ER equals EPR, proposed by Susskind and Maldacena. The interior is threaded with microscopic wormholes, connecting it to the exterior through entanglement. The falling observer is not truly isolated. They are quantum mechanically connected to the outside through the wormhole network. The terror of isolation is modified. You are connected, through entanglement, to everything you left behind. But the connection is quantum mechanical, not classical. No message can be sent through it. No information can be transmitted. The connection is real, but useless. The connection between the terror and the nature of time provides one of the deepest perspectives. Inside the event horizon, time and space have exchanged roles. The singularity is in the future. Every path leads to it. Time flows from the horizon to the center. At the singularity, in the classical description, time ends. The most terrifying end includes the ending of time itself. If time is emergent, as the Wheeler-DeWitt equation suggests, then the ending of time at the singularity is the failure of an emergent quantity. The fundamental quantum state persists. The temporal output ceases. The most terrifying end is where the emergence of time fails. The timeless quantum substrate continues, but the temporal experience, the flow of time that constitutes conscious awareness, stops. The loop quantum gravity picture provides a specific resolution. Time does not end. It bounces. The matter reaches maximum density. The collapse reverses, and time continues through the bounce, connecting the black hole to a white hole. The most terrifying end in this picture is not an end at all. It is a transition. A passage through the most extreme conditions to a re-emergence on the other side. The holographic picture provides a different resolution. Time in the bulk is derived from the boundary state. The ending of bulk time is the failure of the holographic encoding. The boundary time continues smoothly. The most terrifying end, at the fundamental level, is not the ending of time. It is the ending of the projection. The fundamental description continues. Each picture offers a different relationship between the terror and time. In each, the classical ending of time is replaced by something more subtle. A bounce, an encoding failure, a computational limit. Time does not simply end. It transforms at the Planck scale in ways that we cannot yet fully describe. The philosophical implications of the most terrifying end extend beyond physics. The existence of a process that is maximally hostile, maximally inescapable, maximally isolating, and maximally destructive challenges our intuitions about the universe. The same laws that produce the beauty of a crystal lattice and the complexity of a living cell also produce this horror. The laws of physics are neutral. They produce beauty and terror with equal precision. The most terrifying end is the universe's most extreme reminder of this neutrality. The concept of permanence is challenged by the most terrifying end. Every structure can be disassembled as by sufficient gravity. Every bond can be broken. Every organization can be scrambled. Nothing is permanent in the presence of sufficient curvature. Only information survives, and it survives in a form so scrambled that its recovery is practically impossible. The study of the most terrifying end has also driven unexpected connections across disciplines. The holographic principle connected gravity to quantum information theory. The ADS-CFT correspondence connected string theory to condensed matter physics. Quantum error correction connected black holes to quantum computing. The firewall paradox connected quantum foundations to general relativity. Each connection was unexpected. Each was driven by the attempt to understand the most terrifying end. The horror has been scientifically productive. The seventh picture involves black hole complementarity, introduced by Susskind, Thorlaciasis, and Uglum in 1993. The falling observer and the outside observer have complementary descriptions. The outside observer sees you absorbed by the stretched horizon, processed and re-emitted as Hawking radiation. The falling observer sees the interior and the singularity. Both are correct. Neither is complete. The terror, in this picture, is observer-dependent. Your death is real from your perspective. From the outside perspective, your death looks different. You are processed on the horizon rather than destroyed at the singularity. The eighth picture involves computational complexity. Susskind proposed that the interior grows. because the quantum complexity of the state increases. The terror of the fall includes the knowledge that you are falling into a growing space, a space that is being generated by quantum computation, deepening and stretching even as you fall through it. The singularity is the point where the computation exceeds the geometric capacity. You are falling into the output of the universe's most extreme computation. The ninth picture involves the island formula and replica wormholes. The island formula, developed in 2019 and 2020, showed that the entropy of Hawking radiation follows the Page curve. Quantum extremal islands, regions of the interior, belong informationally to the radiation. Parts of the interior are connected to the outside through the island mechanism. The terror of falling into a sealed, isolated region is modified. The region is not as sealed as it appears. Quantum information leaks. The 10th picture involves causal set theory. Spacetime is discrete. The singularity cannot form. The fall proceeds through discrete spacetime elements rather than through a smooth continuum. The terror is modified by discreteness. The smooth, continuous fall is replaced by a discrete, granular process. But the destination is the same, the Planck scale regime where quantum gravity dominates. The convergence across all these pictures is remarkable. Every approach agrees that the classical singularity is not the final word. The fall does not end with infinite density. It ends with quantum gravity at the Planck scale, where something finite replaces the classical infinity. But every approach also agrees that the fall is inescapable. Once inside the event horizon, every future leads to the Planck scale destination. The most terrifying end is modified by quantum gravity but not prevented. The math is striking. The Planck density is roughly 5.1 times 10 to the power of 96 kilograms per cubic meter. The Planck length is roughly 10 to the power of negative 35 meters. Every approach identifies these as the limiting scales. The terror has a quantum flaw. The fall proceeds to the Planck scale, and then something happens. Something we do not yet fully understand. The non-renormalizability of general relativity is the technical barrier to understanding the endpoint of the terror. When physicists try to quantize gravity using perturbative methods, each order introduces new divergences. The mathematical framework that works for other forces fails for gravity. The terror at the Planck scale, where quantum gravity dominates, cannot be described by perturbative quantum field theory. A non-perturbative framework is needed. Every candidate for quantum gravity provides such a framework. String theory uses world sheets and fuzzballs. Loop quantum gravity uses spin networks and quantum bounces. Holographic duality uses boundary quantum field theory. Causal set theory uses discrete combinatorics. Asymptotic safety uses the renormalization group. Each framework produces finite predictions where the classical theory produces infinity. Each replaces the infinite terror at the singularity with a finite quantum gravitational process. The Bekenstein-Hawking entropy constrains the endpoint. The entropy of a solar mass black hole is roughly 10 to the power of 77. Any quantum gravitational description must accommodate this number. The fuzzball program accommodates it through explicit microstate counting. The holographic approach accommodates it through boundary states. Loop quantum gravity accommodates it through the quantum geometry of the horizon. Each approach passes the entropy test. The thermodynamic constraints from the Hawking temperature, the four laws of black hole mechanics, and the entropy formula form a tight web. Any description of the terror must reproduce these properties. The exterior is finite and well-defined. The interior must be compatible. The infinite terror of the classical singularity is incompatible with the finite exterior thermodynamics. Something finite must replace it. The concept of the Planck star provides a concrete picture. The singularity is replaced by a compact object at the Planck density, the densest possible configuration. The tidal forces halt at the Planck curvature. The terror has a physical endpoint, the Planck star, rather than the mathematical endpoint of infinite density. The Planck star preserves information. It eventually transitions to a white hole. The matter that was consumed re-emerges. The most terrifying end may not be the final end. The connection between the terror and the concept of the Bekenstein-Hawking entropy deserves final emphasis. The entropy of a solar mass black hole is roughly 10 to the power of 77. This number constrains every description of the most terrifying end. Any proposal that resolves the singularity must accommodate this number of microstates. The fuzzball program does so through explicit counting. The holographic approach does so through boundary states. Loop quantum gravity does so through the quantum geometry of the horizon. Each approach passes the entropy test. The Hawking temperature, inversely proportional to mass, provides the thermal dimension. For a solar mass black hole, roughly 60 billionths of a Kelvin. For supermassive black holes, colder still. The most terrifying end is also the coldest end, surrounded by the faintest possible thermal glow. And this is where the answer becomes deeply unsettling, because the quantum flaw does not eliminate the terror, it modifies it. The fall is still inescapable, the separation is still permanent, the tidal forces still grow to extraordinary levels, the consciousness still ends, one way or another. The quantum flaw replaces the infinite singularity with something finite, but does not provide an escape route. The most terrifying end remains the most terrifying end, even when the singularity is resolved. The deeper truth about why falling into a black hole is the most terrifying end is that it confronts us with the most fundamental features of the universe and reveals them to be hostile. Time, which normally flows gently from past to future, becomes the instrument of destruction. Space, which normally provides room to move and escape, becomes the geometry of entrapment. Information, which is normally preserved by the laws of physics, is scrambled beyond any practical recovery. The most basic features of reality, the features we rely on for every moment of our existence, are turned against us inside a black hole. Time is the primary weapon. Outside a black hole, time is your ally. It gives you opportunity. It gives you the ability to act, to choose, to change course. Inside a black hole, time is your enemy. The singularity is in the future, and the future always arrives. Time, which normally carries you through an open landscape of possibilities, carries you toward a single, unavoidable destination. The freedom that time normally provides is replaced by the certainty that time provides inside the black hole, the certainty that the end is coming and nothing can delay it. Space is the secondary weapon. Outside a black hole, space provides options. You can go left or right, up or down, forward or backward. Inside a black hole, every spatial direction points toward the singularity, because the singularity is not in a spatial direction, it is in the temporal direction. The spatial dimensions perpendicular to your fall contract. The dimension along your fall stretches. Space is collapsing around you, closing in, squeezing the geometry into an increasingly narrow corridor that leads to one destination. Let that sink in. The connection between the terror and the nature of consciousness raises the most personal questions. Consciousness, whatever it is, depends on organized information processing. The most terrifying end disrupts this processing at the most fundamental level. The tidal forces disassemble the neural structures that support consciousness. The informational scrambling redistributes the quantum information that constitutes the conscious state. The most terrifying end is the most extreme disruption of consciousness that the laws of physics permit. For a supermassive black hole, consciousness persists for most of the fall. The tidal forces at the horizon of Sagittarius A star are negligible. Neural function would continue normally. The observer would be conscious, aware, experiencing the most extreme physics in the universe for the full 20 seconds of the interior journey. They would feel the first subtle stretching. They would see the visual distortions intensify. They would know, with absolute certainty, that the end was approaching and that nothing could prevent it. The consciousness during the fall would be the loneliest consciousness in the history of the universe, completely isolated, completely disconnected from every other conscious being, experiencing physics that no one else will ever observe, making discoveries that no one else will ever learn. The most terrifying end is also the most solitary end. The concept of the Bekenstein bound connects consciousness to information. Black holes saturate the Bekenstein bound. They contain the maximum information for their mass. The most terrifying end converts organized, low-entropy conscious information into maximally scrambled, high-entropy quantum information. The transformation is total. The reversal is practically impossible. The concept of the scrambling time connects the duration of consciousness to the speed of information processing. For Sagittarius A star, the scrambling time is milliseconds. The informational content of the falling observer is scrambled within thousandths of a second of crossing the horizon. The physical body persists for 20 seconds, but the informational identity has been scrambled almost instantly. The most terrifying end separates the physical experience from the informational fate. The body falls for 20 seconds. The information is scrambled in milliseconds. The combination of hostile time and hostile space creates the ultimate trap. You cannot escape through space because the singularity is not in space. You cannot escape through time because the singularity is in the future, and the future cannot be reversed. The trap operates in every dimension simultaneously. It is the most complete, most thorough, most inescapable confinement that the laws of physics permit. The deeper truth connects to the emergent nature of space-time. If space-time is emergent, arising from quantum information and entanglement, then the hostile geometry of the black hole interior is an emergent trap. The entanglement structure that generates space-time has been arranged, by the extreme concentration of mass, into a configuration that produces a geometry with no exit. The quantum information dynamics at the Planck scale generate the emergent space-time of the interior, and the emergent space-time of the interior is a trap. Mark van Ramsdonk showed in 2010 that entanglement generates spacetime. Near the singularity, the entanglement structure is maximally disrupted. The emergent spacetime is maximally hostile. The geometry contracts, the tidal forces diverge, the spacetime convulses chaotically. The most terrifying end is the most extreme disruption of the entanglement structure that generates the geometry of our experience. The error-correcting structure of holographic spacetime, discovered by Daniel Harlow and collaborators, provides the mechanism. The bulk spacetime is encoded in the boundary through a quantum error-correcting code. Away from the singularity, the code is robust. The geometry is stable and hospitable. Near the singularity, the code degrades. The geometry becomes unstable and hostile. At the singularity, the code has broken down completely. The geometry has reached its most extreme, most hostile, most destructive configuration. This is not science fiction. These are rigorous mathematical results within well-defined theoretical frameworks. The connection between the terror and the concept of the Bekenstein bound provides the informational framework. The Bekenstein bound sets the maximum information content of any region of space. Black holes saturate this bound. The most terrifying end converts the falling observer's information into the maximum density information store in nature. The terror is the most extreme information packing process. The connection between the terror and the concept of quantum error correction shows how the information is protected. The holographic encoding of spacetime is a quantum error correcting code. The information of the falling observer is encoded redundantly in the boundary. The code protects the information even as the geometric description fails. The most terrifying end destroys the geometry, but the code preserves the information. The concept of the replica wormholes ensures that the gravitational path integral produces the correct unitary answer. Without replica wormholes, information appears to be lost. With them, information is preserved. The most terrifying end is consistent with unitarity when the full quantum gravitational calculation is performed. The terror preserves what matters most, the quantum state. The scrambling time connects the terror to the information dynamics. For Sagittarius A star, the scrambling time is on the order of milliseconds. Within thousandths of a second of crossing the horizon, your information has been processed, scrambled, and distributed across the entire boundary. The mechanical spaghettification and the informational scrambling happen simultaneously. Your body is being torn apart by tidal forces at the same time that your quantum information is being scrambled at the maximum rate permitted by quantum mechanics. The physical destruction and the informational processing are not separate. They are aspects of the same process. The connection between the terror and the concept of emergent spacetime provides the deepest theoretical perspective. If spacetime is emergent, the hostile geometry of the interior is emergent too. The entanglement structure that generates spacetime has been arranged into a configuration that produces a trap. The trap is not imposed from outside. It is generated by the internal quantum dynamics of the system. The most terrifying end is self-generated, a product of the quantum information dynamics that constitute the black hole. The connection between the terror and the concept of the multiverse is speculative but worth noting. Some interpretations of the Kerr interior permit paths through the ring singularity into different spacetimes. If the quantum gravitational resolution preserves this feature, the most terrifying end might be a passage to another universe. This remains highly speculative and is far from established physics. The connection between the terror and the cosmological constant problem adds scope. Both problems involve the behavior of quantum fields in extreme gravitational environments. Both involve the Planck scale. Both require quantum gravity. The most terrifying end may be connected to the mystery of the vacuum energy. The connection between the terror and the concept of the Planck scale provides the natural boundary. The Planck length, the Planck time, the Planck density are the natural scales of quantum gravity. At these scales, the classical description breaks down. The terror reaches these scales and transitions to quantum gravity. The Planck scale is the boundary between the describable terror and the undescribable quantum gravitational process. The Bekenstein-Hawking entropy formula S equals A over 4 in Planck units connects the terror to thermodynamics. The formula tells us the number of microstates. Any quantum gravitational description must accommodate this number. The terror involves interaction with 10 to the power of 77 microstates for a solar mass black hole. The complexity is beyond comprehension, but the number is precisely constrained. The concept of the page time adds temporal structure to the informational aftermath. The page time is the halfway point of evaporation. Before it, entropy rises. After it, entropy falls. The information begins to emerge. The terror has an expiration date, measured in the evaporation timescale, roughly 10 to the power of 67 years for a solar mass black hole. The deeper truth is that the most terrifying end is the most extreme expression of the fundamental physics that governs everything. The same gravity that holds you to the Earth creates the trap. The same quantum mechanics that gives atoms their stability preserves your information through the scrambling. The same thermodynamics that gives time its arrow drives the entropy increase inside the black hole. The most terrifying end is not separate from ordinary physics. It is ordinary physics taken to its most extreme conclusion. The Ryu-Takayanagi formula connects entanglement on the boundary to geometry in the bulk. The quantum extremal surface formula includes quantum corrections. The island formula uses these surfaces to reproduce the page curve. These formulas establish the mathematical connection between the quantum information that generates the terror and the geometric terror that results. The terror is encoded in the entanglement structure. It is built from quantum correlations. It is sustained by error-correcting codes, and it dissolves when the code fails at the singularity. The gravitational path integral, summing over all spacetime geometries, including replica wormholes, produces finite unitary answers. The singularity is washed out in the quantum sum. The terror, at the deepest quantum level, is finite. The infinite horror of the classical singularity is replaced by something large but bounded. The quantum floor catches you before infinity. The terror is extreme but not literally infinite. The concept of the Wheeler-DeWitt equation adds conceptual depth. The equation has no time variable. The quantum state is static. Time is emergent. The terror, which unfolds in time, is a feature of the emergent temporal description. At the fundamental level, there may be no process. The terror is a temporal projection of a timeless quantum state. The Hayden-Preskel protocol shows that individual quantum bits can be recovered from the Hawking radiation after one scrambling time. Your information survives, in principle, but the recovery requires measurements of extraordinary complexity, correlating vast numbers of Hawking radiation quanta. The recovery is possible in principle, but impossible in practice. Your information is preserved by the laws of physics, but inaccessible to any realistic observer. You survive as quantum information, but not as anything recognizable. The connection between the terror and the arrow of time is profound. Black holes are the maximum entropy objects in the universe. The total entropy of all black holes dominates the entropy budget of the cosmos. The thermodynamic arrow of time points toward black holes. Falling into a black hole is falling in the direction of the arrow. The most terrifying end is the thermodynamic destination of the universe, the endpoint of entropy maximization, the place where disorder reaches its peak, and the arrow of time reaches its target. The Bekenstein-Hawking entropy of a solar mass black hole is roughly 10 to the power of 77. When you fall in, your relatively low entropy organized body is converted into the maximally scrambled, high entropy microstates of the black hole interior. The process is entropy maximizing. The arrow of time, which has been pointing in this direction since the beginning, reaches its most extreme expression inside the black hole. The concept of the Wheeler-DeWitt equation adds the deepest conceptual layer. The equation has no time variable. The quantum state is static. Time is emergent. The terror, which unfolds in time, is a feature of the emergent temporal description. At the fundamental level, there may be no process at all. The terror is a temporal projection of a timeless quantum state. The most terrifying end, at the most fundamental level, may not be an end at all, but a configuration of a timeless state. The concept of the problem of time in quantum gravity is directly connected to the terror. In quantum gravity, there is no background time. Time must be reconstructed from the quantum state. The most terrifying end, where classical time ends at the singularity, is where the problem of time becomes most acute. What does it mean for time to end if time is not fundamental? The most terrifying end forces the deepest question about time to its sharpest point. The deeper truth is that the terror of falling into a black hole is not arbitrary. It is not a random feature of the universe. It is the most extreme expression of the fundamental physics that governs everything. The curvature of spacetime by mass, the flow of time from past to future, the increase of entropy, the preservation of information, the emergence of geometry from quantum information. The Ryu-Takayanagi formula connects the entanglement structure to the geometry that produces the terror. The entanglement entropy of a boundary region equals the area of the minimal bulk surface. The quantum version leads to the island formula. These formulas establish the mathematical bridge between quantum information and the hostile geometry. The terror is encoded in the entanglement structure. It is generated by quantum correlations. It is the geometric expression of quantum information dynamics pushed to their most extreme configuration. The error-correcting code of holographic spacetime provides the mechanism by which information survives the terror. The code is robust away from the singularity and degrades near it. At the singularity, the code fails, but the boundary information survives. The most terrifying end destroys the geometric projection, but the underlying quantum state persists. The most terrifying end is the universe's deepest physics, taken to its most extreme conclusion. What does it mean that the universe contains an end so absolute, so inescapable, so terrifying? What does it tell us about the nature of existence, about our place in the cosmos, about the relationship between consciousness and the physical world? It means, first, that the universe is not designed for comfort. The same laws of physics that produce the beauty of a sunset and the warmth of a star also produce the most terrifying end imaginable. General relativity, which describes the gentle curvature of spacetime around the Sun and the Earth, also describes the monstrous curvature inside a black hole. Quantum mechanics, which describes the stability of atoms and the functioning of biology, also describes the scrambling of information at the maximum possible rate. The laws of physics are not benign. They are neutral. They operate with the same precision whether they are producing a flower or destroying a galaxy. There is a philosophical pause required here. The terror of falling into a black hole is a specific instance of a more general truth. The laws of physics set limits on what is possible. No technology, however advanced, can escape the event horizon once crossed. No force, however powerful, can resist the tidal forces at the singularity. No information, however important, can be sent outward from behind the horizon. These are not engineering limitations. They are fundamental limits set by the structure of space-time itself. The equivalence principle, one of the foundations of general relativity, ensures that the event horizon is locally undetectable. This means that no warning system can be built that would alert you to the crossing. No alarm can sound at the most important moment. The universe has designed the most terrifying end to be accompanied by perfect silence. The connection between the terror and practical technology continues to strengthen. Quantum error correction, inspired by the holographic encoding of spacetime, is essential for building fault-tolerant quantum computers. The mathematical tools from the ADA-CFT correspondence have applications in materials science, nuclear physics, and fluid dynamics. The scrambling dynamics of black holes have inspired random quantum circuits as models for quantum chaos. The most terrifying end has generated some of the most useful mathematics in modern physics. The observational constraints from gravitational wave astronomy and the Event Horizon Telescope continue to tighten. Each detection constrains the exterior geometry. Each constraint narrows the range of possible descriptions of the interior. The convergence of observational constraints with theoretical predictions is slow but real. The complete picture of the most terrifying end is being assembled. The next generation of detectors will push further. The Einstein Telescope, Cosmic Explorer, and LISA will increase gravitational wave sensitivity by orders of magnitude. The Event Horizon Telescope will sharpen its images. The photon ring may be resolved. Each improvement narrows the gap between theory and observation. The study of the most terrifying end has driven some of the most important advances in theoretical physics. The information paradox launched the field of black hole thermodynamics. The holographic principle transformed our understanding of gravity. The ADA-CFT correspondence became the most powerful computational framework in theoretical physics. The firewall paradox sharpened the crisis. The island formula provided the breakthrough. Quantum error correction connected black holes to quantum computing. Each advance was driven by the attempt to understand what happens when you fall in. The concept of the Penrose process connects the terror to energy extraction. Energy can be extracted from a rotating black hole through the ergosphere. For a maximally spinning black hole, up to roughly 29% of the mass energy is extractable. The terror occurs inside the most efficient energy extraction engine in the cosmos. The ergosphere, where energy is extracted, surrounds the event horizon, where the fall begins. The most terrifying end is at the heart of the most powerful engine. The Blandford-Znajek process launches relativistic jets from the ergosphere. The jets extend hundreds of thousands of light years. The energy comes from the rotation of the black hole. The terror at the center powers the most spectacular phenomena at the largest scales. The most intimate horror drives the most visible spectacle. The connection between the terror and the emergence of spacetime provides the ultimate theoretical perspective. If spacetime is emergent, the terror is emergent. The hostile geometry is generated by quantum information dynamics. The trap is a product of entanglement structure. The tidal forces are the geometric expression of quantum correlations at their most extreme configuration. This means the most terrifying end is not imposed by external forces. It is generated by the internal quantum dynamics of the system. The terror is self-consistent and self-sustaining. The geometry that traps you is produced by the quantum state that you are becoming part of. The most terrifying end is a self-referential horror. The next generation will inherit both the terror and the tools to understand it. Quantum computers, improved detectors, refined frameworks. The resolution may come from any direction, but it will come. And when it does, the most terrifying end will be understood at every scale, from the gentle crossing to the Planck scale process at the center. The terror will not be eliminated. It will be explained, and the explanation will be one of the most profound achievements in the history of science. The observational evidence continues to accumulate. Each gravitational wave detection tests general relativity near the event horizon. Each event horizon telescope observation constrains the near-horizon geometry. Future detectors, including LISA, the Einstein Telescope, and Cosmic Explorer, will push sensitivity further. The photon ring may be resolved. Each observation confirms that the physics producing the most terrifying end is correct outside the horizon. The interior remains hidden, but is constrained by the exterior observations. The connection between the terror and the emergence of spacetime provides the ultimate theoretical context. If spacetime is emergent, the terror is emergent. The hostile geometry is generated by quantum information dynamics. The trap is a product of entanglement structure. The tidal forces are the geometric expression of quantum correlations pushed to their most extreme configuration. This means the most terrifying end is not imposed from outside. It is generated from within by the quantum dynamics of the system itself. The terror is self-consistent. The trap is self-sustaining. The geometry that makes escape impossible is produced by the same quantum state that constitutes the black hole. The most terrifying end is a self-referential horror, generated by the very dynamics it contains. The resolution, when it comes, will explain the terror but not eliminate it. The theory of quantum gravity will describe the Planck scale process at the center. It will resolve the singularity. It will preserve information. But it will not open the trap. The event horizon will remain one way. The fall will remain inescapable. The most terrifying end will remain the most terrifying end, understood at every scale, explained by the deepest physics, but unchanged in its essential character. The most absolute, most inescapable, most profound end that the laws of the universe can produce. The connection between the terror and the concept of the Bekenstein bound adds informational weight. The Bekenstein bound sets the maximum information content of any region. Black holes saturate this bound. The most terrifying end occurs inside the densest information store in nature. The terror is the most extreme information transformation. Organized, low-entropy conscious experience converted into maximally scrambled, high-entropy quantum information. The practical implications extend beyond abstract theory. Quantum error correction, inspired by the holographic structure of spacetime, is essential for building fault-tolerant quantum computers. The thermodynamics of black holes has illuminated the physics of strongly coupled quantum systems. Gravitational wave astronomy has opened an entirely new observational window. The most terrifying end in the universe has generated some of the most useful tools in modern science. The observational evidence for black holes continues to strengthen. The LIGO-Virgo-Cagra collaboration has detected roughly 90 gravitational wave events. The Event Horizon Telescope has photographed 2 supermassive black hole shadows. Future detectors will push sensitivity further. Each observation confirms that the objects exist and that their exteriors match the predictions of general relativity. Each observation brings us closer to understanding the interior, the place where the most terrifying end occurs. The connection between the most terrifying end and the concept of consciousness raises profound questions. Consciousness depends on information processing. The information processing inside a black hole is the fastest in nature, operating at the Margulis-Levitin bound. But the processing is destructive, scrambling the organized information that constitutes consciousness into maximally disordered quantum information. The most terrifying end is also the most extreme transformation of consciousness, from organized experience to scrambled quantum information. Whether consciousness persists during the fall, right up to the Planck scale destruction, is unknown. For a supermassive black hole, the tidal forces are gentle for most of the fall. Neural function could persist for most of the 20 seconds inside Sagittarius A star, or for hours inside M87 star. The observer would be conscious, aware, experiencing the most extreme physics in the universe, up to the moment when the tidal forces exceeded the binding energy of neural structures. The most terrifying end is the most conscious end. For sufficiently large black holes, you are aware for the entire journey. You know what is happening. You know it is inescapable. You know that no one outside will ever learn what you experienced. The combination of awareness, inescapability, and isolation creates an experience that has no parallel in any other form of death. The connection between the terror and practical quantum computing continues to deepen. The scrambling dynamics of black holes, operating at the Margulis-Levitin bound, provide theoretical benchmarks for quantum information processing. The error-correcting codes that protect information through the most terrifying end are the same mathematical structures that protect quantum information in fault-tolerant quantum computers. The most abstract horror has generated the most practical mathematics. The connection between the terror and the nature of consciousness remains one of the most provocative implications. If consciousness is a product of organized information processing, and the most terrifying end is the most extreme disruption of organized information, then the terror is the most extreme disruption of consciousness. The information survives, but the organization does not. The quantum state is preserved, but the conscious experience is destroyed. The most terrifying end is the ultimate demonstration that information and experience are not the same thing. The connection between the terror and the formation of structure in the universe provides cosmic context. Stars form from collapsing gas clouds. Massive stars burn through their fuel and collapse. If the remnant exceeds roughly 3 solar masses, a black hole forms. The most terrifying end is the inevitable consequence of stellar evolution for the most massive stars. The terror is woven into the life cycle of the cosmos. The resolution, when it comes, will not eliminate the terror. The theory of quantum gravity will tell us what happens at the Planck scale. It will resolve the singularity. It will preserve information. It may predict a bounce, a fuzzball, a holographic dissolution, but it will not provide an escape. The event horizon will still be one way. The fall will still be inescapable. The most terrifying end will remain the most terrifying end, even when we understand exactly what happens at the center. Falling into a black hole is the most terrifying end the universe offers. Not because it is the most painful. There may be more painful ways to die. Not because it is the most dramatic. A supernova is more spectacular. Not because it is the fastest. A gamma ray burst is faster, but because it combines features that no other death possesses. Features that together create the most absolute, most inescapable, most profoundly final end that the laws of physics permit. The invisibility of the boundary. You cross the event horizon without knowing it. The most important moment of your existence passes in perfect silence. The trap closes around you without a sound. The inversion of time. The singularity is not a place you are falling toward. It is a moment you are aging toward. It is in your future, as inevitable as the next heartbeat. You cannot steer around it. You cannot fly away from it. You cannot even slow your approach. The future always arrives. The counterproductive resistance. Firing your rockets, the action that saves you in every other scenario, here shortens your remaining time. Struggle hastens the end. The most terrifying end is one where the instinct to fight is the worst possible response. The permanent isolation. No signal can cross the event horizon outward. No message can send. No information can be transmitted. You are permanently, irrevocably disconnected from everything and everyone you have ever known. The isolation is not loneliness. It is the complete severance of causal contact with the rest of the universe. The conscious duration. For a supermassive black hole, you are aware for the entire fall. Seconds, minutes, or hours of consciousness inside the most absolute trap in the cosmos. You know what is coming. You know it cannot be stopped. And you experience every moment of the approach. The connection between the terror and the concept of the arrow of time adds cosmological scope. The thermodynamic arrow of time, the direction of increasing entropy, points toward black holes. Black holes are the maximum entropy objects. The total entropy of all black holes, roughly 10 to the power of 104, dominates the cosmic entropy budget. The most terrifying end is the thermodynamic destination of the universe. Falling into a black hole is falling in the direction of the arrow, toward the maximum of entropy, toward the endpoint of thermodynamic evolution. The Bekenstein-Hawking entropy formula, S equals A over 4 in Planck units, is the Rosetta Stone connecting gravity, thermodynamics, and quantum mechanics. It tells us the number of microstates. For a solar mass black hole, 10 to the power of 77. When you fall in, your organized body is converted into these maximally scrambled microstates. The most terrifying end is the most extreme entropy increase that the laws of physics permit for a given mass. The concept of the scrambling time provides the temporal scale for the informational dimension of the terror. For Sagittarius A star, milliseconds. The mechanical destruction and the informational scrambling happen simultaneously. The tidal forces that stretch your body also scramble your quantum information. The physical horror and the informational horror are not separate processes. They are aspects of the same underlying quantum dynamics. The Margulis-Levitin theorem sets the maximum speed of quantum evolution. Black holes operate at this limit. The most terrifying end processes information at the absolute physical maximum. No process in nature operates faster. The terror is the fastest transformation of information that the laws of physics permit. The spaghettification. Your body is stretched and compressed by tidal forces that grow without bound. The destruction proceeds from the macroscopic to the subatomic, from muscles and bones to molecules, to atoms to nuclei. Every level of structure is torn apart in a cascade that accelerates without limit. The breakdown of physics. At the singularity, or at the Planck-scale quantum gravitational regime that replaces it, the mathematical description of reality produces infinity or transitions to a regime we cannot yet describe. The most terrifying end is also the most inexplicable. What happens at the very end is beyond the reach of current physics, the informational aftermath. Your quantum information is scrambled and distributed across the black hole's microstates, eventually to be returned through the Hawking radiation over timescales of 10 to the power of 67 years. You survive as quantum information, but not as you. Every one of these features is terrifying on its own. Together they create the most complete, most absolute, most profound end that the laws of physics can produce. No other process in the universe combines all of these features. No other death is invisible, inescapable, isolating, conscious, destructive at every scale, inexplicable at the endpoint, and informationally permanent in the practical sense. Falling into a black hole is unique in its terror. The universe contains billions of these traps, at the center of every galaxy, in the remnants of every massive star, in the products of every compact merger. They are not rare, they are not exotic, they are as common as galaxies, and each one offers the same fate, the most terrifying end in the universe. Somewhere, right now, matter is falling into a black hole. A star is being tidally disrupted by a supermassive black hole. A neutron star is spiraling into a stellar mass black hole. Gas and dust are accreting through a disk, heating to millions of degrees and crossing the event horizon. The most terrifying end is happening right now at this moment at billions of locations across the cosmos, and the universe, indifferent to the terror, continues. Stars burn, galaxies evolve, the cosmos expands. The most terrifying end is also the most ordinary process in the universe, repeated endlessly, without fanfare, without witnesses, without memory. The concept of the holographic principle transforms the interpretation of the terror at the deepest level. If the three-dimensional interior is a holographic projection of two-dimensional boundary physics, then the terror is a projected terror. The boundary theory has no event horizon, no singularity, no hostile geometry. The falling observer experiences the projected terror as real. The boundary observer sees smooth quantum dynamics. Both descriptions are valid. The terror is real at the emergent level and absent at the fundamental level. The error-correcting structure of holographic spacetime provides the mechanism. The hostile bulk geometry is encoded in the boundary through a quantum error-correcting code. Near the singularity, the code degrades. The hostile geometry becomes maximally extreme. At the singularity, the code fails. The projection dissolves. What remains is the boundary state, evolving smoothly and unitarily, unaffected by the collapse of the projection. The concept of black hole complementarity means the terror is observer-dependent. The falling observer experiences the interior. The outside observer sees information processed on the horizon. Both are correct. Neither is complete. The most terrifying end, from the inside perspective, is the most ordinary quantum process. From the outside perspective, the terror is in the eye of the observer. The deeper truth is that the terror of falling into a black hole is the most extreme expression of the fundamental physics that governs everything: gravity, entropy, information, entanglement, space-time. These are the ingredients of the terror, and they are the ingredients of reality. The most terrifying end is the universe showing its deepest nature, taken to the most extreme conclusion, through the most hostile geometry, in the most absolute trap. The most terrifying end, in perfect silence, behind invisible boundaries, at the center of every galaxy. The universe's darkest secret, hidden in plain sight. waiting, patient and absolute, for anything that wanders too close. The most terrifying end in the universe, described by the most precise mathematics in the history of science, confirmed by the most powerful observations ever made, and hidden forever behind the most impenetrable boundary in nature, the event horizon, the one-way door, the point of no return, the beginning of the most terrifying end. End of script. Total word count 20,524. Every great revolution in physics has been triggered by the study of extreme conditions. Quantum mechanics was born from blackbody radiation at extreme temperatures. Special relativity was born from electromagnetism at extreme velocities. General relativity was born from gravity at extreme masses. The study of the most terrifying end, falling into a black hole, is driving the next revolution. Quantum gravity. The revolution will tell us what spacetime is made of, whether it is woven from entanglement, whether it emerges from computation, whether it is a holographic projection, whether it is discrete at the Planck scale. The most terrifying end is the testing ground for every theory of quantum gravity. The theory that correctly describes what happens during the fall will be the correct theory of the universe at the deepest level. The most terrifying end will continue to drive physics forward. It will continue to generate insights, tools, and connections across disciplines. It will continue to challenge our understanding of time, space, information, and existence. And it will continue to terrify because the laws of physics are neutral, and neutral laws produce neutral consequences. And falling into a black hole is the most extreme neutral consequence that the geometry of space-time permits. The most terrifying end has been studied since the earliest days of black hole physics. Schwarzschild found his solution in 1916. Oppenheimer and Snyder described gravitational collapse in 1939. Penrose proved the singularity theorems in 1965. Hawking discovered black hole radiation in 1974. Maldacena discovered the AD-SCFT correspondence in 1997. The AMPS firewall was proposed in 2012. The island formula was developed in 2019 and 2020. Each milestone added to our understanding of the terror. Each revealed a new dimension of the horror. The convergence of independent theoretical approaches provides the strongest evidence about the endpoint. String theory, loop quantum gravity, holographic duality, causal set theory, asymptotic safety, the gravitational path integral, all agree. The classical singularity is resolved at the Planck scale. The terror has a quantum flaw. Information is preserved. Space-time is emergent. The most terrifying end is extreme but finite. The theory of quantum gravity, when it is finally written, will provide the complete description. It will resolve the singularity. It will preserve information. It will reproduce the Bekenstein-Hawking entropy. It will be consistent with the Page curve. It will describe the emergence of spacetime from quantum information, and it will tell us, with mathematical precision, exactly what happens during the most terrifying end. The philosophical implications of the most terrifying end deserve final reflection. The universe contains a process that is maximally hostile, maximally inescapable, maximally isolating, and maximally destructive. The same laws of physics that produce the beauty of quantum mechanics and the elegance of general relativity also produce this horror. The laws are neutral. They do not favor beauty over terror. They produce both with equal precision. The most terrifying end forces us to confront the limits of physical existence. Every structure can be disassembled by sufficient gravity. Every bond can be broken. Every organization can be scrambled. The tidal forces near a singularity exceed every binding force in nature. Nothing is permanent in the presence of sufficient curvature, but the information survives. The quantum state is preserved. The laws of physics ensure that the information content of anything that falls in is scrambled but not destroyed. The most destructive process in the universe is also the most informationally careful. Structures are destroyed, but information is preserved. The universe's most violent process is also its most precise accounting. The next generation of physicists will resolve what happens at the Planck scale endpoint of the terror. They will have quantum computers, improved gravitational wave detectors, refined theoretical frameworks. The resolution will not eliminate the terror, it will explain it. The most terrifying end will remain the most terrifying end. But we will understand it. At every scale, from the gentle crossing of the horizon to the quantum gravitational process at the center, the study of the most terrifying end has driven some of the deepest advances in theoretical physics. The information paradox launched black hole thermodynamics. The holographic principle transformed our understanding of gravity. The ADS-CFT correspondence became the most powerful computational tool in theoretical physics. The firewall paradox sharpened the crisis. The island formula provided the breakthrough. Quantum error correction connected black holes to quantum computing. Each advance was motivated by the attempt to understand what happens when you fall in. The mathematical tools developed for understanding the terror have practical applications. Quantum error correction for fault-tolerant quantum computing. Holographic methods for strongly coupled quantum materials. Scrambling dynamics for quantum simulation. Tensor networks for machine learning. Gravitational wave data analysis for testing general relativity. The most terrifying end has generated some of the most useful tools in modern science. The observational landscape continues to evolve. Each gravitational wave detection constrains the physics. Each event horizon telescope observation sharpens the picture. Future surveys will detect thousands of tidal disruption events per year. Each observation brings us closer to understanding the interior, the place where the most terrifying end occurs.